This video is for my Math 378 students. It's Problem 10-70. It's a t-test, 2-sample. You can read the description here, pause the video and read it. I'm not going to read it to you. And the data is also provided in the table. Part A requires us to test the hypothesis that the mean amount of DDT in juveniles and nestlings do not differ versus the alternative that the juveniles have a larger mean. This is a test of two means. Our null hypothesis is that the mean, I'll use a subscript J for the juveniles, our mean for the juveniles minus our mean for the nestlings, I'll use a subscript N, is equal to 0, versus the alternative. In this case, the juveniles are greater than the nestlings, so this is greater than 0. If you like, you could write it by putting the nestlings on the right-hand side. I like to write it with them all on one side because it'll tell me what to use in the null hypothesis. Also, it looks like for this problem we're going to use an alpha of 0.05. We're ready to go. This is a 2-sample, one-sided. Now we just need our test statistic. In this case, we're going to use the difference of the juveniles and the nestlings in terms of y bar. Since it's a t, I got to subtract off the hypothesized mean. And I'm going to divide it by a pooled standard deviation. I'm assuming equal variance plus the sum of 1 over the number of juveniles and 1 over the number of nestlings. That's our test statistic. It's a t, and it has n, so j plus n sub n minus 2 degrees of freedom. And we'll see, we want to compare that with a t. Let's draw a picture to make sure we're looking at this right. Under the null hypothesis, it's going to be a t, which is centered at 0. And we're going to want to reject, if we're in the upper tail, by looking at the alternative. For this area to the right is 0.05. This will be our k value, which our book calls t sub alpha. And I think that's it. I think we have all the information that we need. So let's go to R and start calculating some of these values. Here in R, a couple things to notice. I have a function already inputted that calculates the pooled standard dev. You can look at the formula, pause and look at the formula straight from the book. Alright, we're ready to go. So first thing we need to do is calculate our test statistic. So I am going to take my sample mean for the two cases. I actually have the formula right down here. I'm going to copy and paste it up and then you can look at it. Alright, so I'm taking the sample mean for the juveniles minus the sample mean for the nestlings, subtracting off the hypothesized difference, which is under the null, which is 0, and divided by the pool standard dev times the square root of 1 over 10 plus 1 over 13. That's our test statistic. And that comes out to be 2.96. I need to compare that with my t value, which is a quantile from the t distribution. It'll be qt. The area to the left of k is 0.95, and the degrees of freedom, 10 plus 13 minus 2. So that's 21. And this will give us the k value, which is 1.17. And that's all the information I need. That information on our note sheet. Right. Again, our t, I'm going to call it little t, was 2.97. And then our k value, which came from what the book would call t sub alpha, is 1.72. We're to the right. We're in the rejection region. So in words, I would say I'm 95% confident that based on this data, the mean levels of DDT in the brains of juvenile brown pelicans is greater than the mean levels of DDT in the brains of nestling brown pelicans. And next thing we want to do is to calculate a p-value. It's not required for this problem. Let's go ahead and calculate the p. Remember the definition of p-value. It's given that the null is true. It's the probability that our test statistic, in this case t, will be as extreme or more extreme than the sample value, mu juvenile minus mu nestling, equals 0. And that's the probability we're going to want to calculate in R. All right, here we're going to calculate the p-value. It's area to the right, and that's, I'm going to pull up my test statistic. I don't want any round off errors, so I'm just going to have it calculate that value again. And again, I have 21 degrees of freedom. I'm using 1 minus that probability because it gives me the area to the left. I want area to the right. And it looks like my p-value is 0.0037. 0.0037. Interpretation, given that there was no difference in the mean rates between juvenile and nestlings, probability that I would observe the sample numbers that I did, that being 0.041 and 0.026, is 0.003. Very unlikely, therefore I reject. Now we're going to do part B. I'll go ahead and let you read it. Pause the video if you need a second. All right. Slight change in the hypothesis. Here, the null hypothesis again, the mean for the juveniles minus the mean for the nestlings. In this case, we're saying that that difference is 0.01. The alternative, the juveniles exceed the mean for the juveniles exceeds the means for the nestlings by more than 0.01. All that's going to happen in our test statistic, we're going to still have y1 minus y2, but now under the null, that difference is not 0, it's 0.01. We're still going to take the spooled times the square root of juveniles over the number of nestlings. Everything's the same, except now we have a difference we want to check for, and we can do this in R quickly. Luckily, we can use a lot of the same commands we already had done. We use the up arrow key to find them. If we like, our test statistic here is exactly the same, except now I need to subtract off 0.01. And now it looks like our test statistic's 0.9891. Of course, we're going to compare that with the same value we had before, which is 1.72. In this case, we failed to reject. And if we like to do a p-value, again, everything's going to stay the same, except we're going to subtract off 0.01. So I can use all these same commands, don't have to retype everything. Looks like the p-value's around 17%. Let's write our numbers down real quick. Our sample test statistic was 0.989. We're comparing that with a critical value, what I'm calling K, our book would call T alpha, which we saw up above was the same, 1.72. I'm to the left, so I failed to reject. Or we could look at the p-value. Again, it's failed to reject the null hypothesis. Or I can look at the p-value, which was 0.17, given that the difference between the juveniles and the nestlings in terms of their mean DDT, if it was really 0.01, the probability I could get my sample data or data more extreme is 17%. Pretty high probability. Again, I failed to reject the null hypothesis. And that's homework problem 1070.